Okay, now going back to what we have regarding the topic of slope, we're going to carry over to what will be regarded as the average rate of change of a function. Now again, we have with the slope formula, we have the slope m is equal to the change in y with respect to the change in x, where we have represented by y of 2 minus y of 1 all over x of 2 minus x of 1, again where we have that x of 1 and x of 2 cannot equal each other. And the slope formula applies also to the average rate of change of a function. Now we have for the average rate of change of a function, we have whereupon if we have the function in the form of y is equal to f of x, then the average rate of change of this function between 2 points, and putting in the context of functional notation, where we have x of 1, y of 1 is equal to x of 1, where we have y of 1 in the form of f of x of 1, and we also have going through the second order pair where we have x of 2, y of 2 is equal to x of 2, f of x of 2. Again, f of x of 2 is a functional notation for what we have in y of 2. Now for the average rate of change of a function, okay, we have applying slope, and now where the function is nonlinear, okay, the type of line that will be connecting the 2 points of interest will be regarded as a secant line. So we have for the slope, if you notice for the subscript to SEC, that means just the slope of the secant line or the slope of the line that will be connecting the 2 points of interest. Okay, so for the slope of the secant line or the average rate of change of a function, again, you're still going upon the premise of the change of y with respect to the change of x, where you have in the form of f of x of 2 minus f of x of 1 all over x of 2 minus x of 1, again, where neither x of 1 nor x of 2 can be equal to each other. Now, in looking at the average rate of change of a function, and we'll say, for instance, okay, if we have the function along the lines of y is equal to f of x equals x squared plus x, and say if we were to determine the average rate of change between x equals 1 and x equals 3. Right. So in establishing what we have here, so we have given x values. Now if we look for the corresponding y values, and we have in the setup, so if we have at x is equal to 1, we're going to have for the corresponding y value, we have y is equal to f of 1, and for f of x equals x squared plus x, okay, if I plug in 1 for x, and we have 1 squared plus 1. 1 squared plus 1 is going to be 1 plus 1, which is going to be equal to 2. Now for what we have at x equal to 3, we're going to have for the corresponding y value. So we have the y is equal to f of 3, and for the representation of x squared plus x, so we're going to have 3 squared plus 3. 3 squared is 9, and 9 plus 3 is 12. And we have with the average rate of change, okay, that occurs between x equals 1 and x equals 3 along the graph of y equals f of x equals x squared plus x. Now for the average rate of change, for the slope of the secant line, again we have f of x of 2 minus f of x of 1 all over x of 2 minus x of 1. And again, so we have, so you're looking at x of 2 is at 3, and x of 1 we have at 1, again going from x equals 1 to x equals 3, and for the shift in x, so we're looking at 3 minus 1. So f of 3 again, that is going to be at 12, and f of 1 we have at 2, again 3 minus 1 is going to be at 2, and the change in y is going to be at 10, change in x again is going to be at 2. So for the slope, in this case, average rate of change between x equals 1 and x equals 3 along the graph of y is equal to x squared plus x, that is going to be 5 units. But now let's say that if I go out further, and say if I go from x equals 1 to x is equal to 6, and again, we have in our foundation, we have y is equal to f of x is equal to x squared plus x. I'm using the same function. And just upon repeating. So again, we have x is equal to 1. Okay, so I have y is equal to f of 1. And we have is equal to 1 squared plus 1. One squared is 1. 1 plus 1 is 2. And now going out further, instead of going out to x equals 6, and now I'm going out to x equals 3, I'm now going out to x is equal to 6. So you have y is equal to f of 6. So you have 6 squared plus 6. 6 squared is 36. And 36 plus 6 is going to come out to 42. Now, in the case of taking what we have for the average rate of change, okay, so we have for the slope of the secant. All right, so we're going to have, in this particular regard, okay, so we're going to have, once again, so we have f of 6 minus f of 1 all over 6 minus 1. So f of 6 we have at 42. We have minus f of 1, which we have at 2. And this time around we have the shift is going to be 5 units. So we have 40 over 5. And so that will come out to 8. All right. And looking at comparing and contrasting what we have here. All right. And if you notice, okay, for what we have in the graphs, okay, we have the secant line going from x equals 1 to x equals 3. Okay, notice you have connecting the dots with the straight line, which you have as a blue color. Okay, now that slope is going to be 5 units, but if I were to expand the model going from x equals 1 to x equals 6, and we have connecting the dots, and it turns out that the rate of change is increasing, and going from x equals 1 to x equals 6 directly, I have a slope value of 8.